We have organized a panel discussion to understand the ripple effect of energy transition topics like decarbonization and new energies on hard-to-abate industries. I'm sure your company has initiated actions to reduce Scope 1, 2, or 3 emissions. Feel free to put your comments in the window as the discussion happens over here. Let us now discuss with our panel of industry experts to understand how industries are coping with energy transition topic. In the panel today, we have Rob Vermeulen, Philip Koenen, Prashant Srikumar, and Vernon Moodley, representing oil and gas, chemical, and mining industry sector. So now let's head over to the panel. So Rob, my first question is for you. When we talk of energy at this moment, it's mostly coming from crude oil. 90 plus million barrels of oil is produced every day, and it is also refined every day. So when energy transition happens, what will happen to these refineries, or what will the refinery of the future look like?
So you have an hour for me to answer this question?
Sure.
No, it's a great question, because there's a lot going on in the refineries. Refineries were always known that the margins that they were making in refineries were so-so, and what do you do when your margins are not to where they need to be in order to be economical, sustainable over time? Is that you increase your efficiency. So you see a lot of efficiency being addressed within the refinery processes at the moment. Bottom of the barrel discussion, where you try to avoid the amount of coke. The FCC discussion, where you try to optimize the catalytic process in the refineries as well. You try to make the control balances within the refinery tighter, mass balance within refineries. So there's a lot of activities going on in order to improve the efficiency. That's one part of it. Then the second part of it is, of course, that also refineries produce a lot of greenhouse gases, CO2. And what do you do with that CO2? Years ago, in the Netherlands, for instance, CO2 was pumped to the greenhouses to help grow plants,
increase the
crops.
Production efficiency.
Exactly, in that. But nowadays, you see in the Middle East and also other places that they take the CO2 out of the refineries and use it for enhanced oil recovery. So it's both helping increase the efficiency of the upstream part.
That's right.
At the other hand, it also, you store that stuff underground and it will never come up. Yeah. So that's another thing that's happening in refineries as well. So you have efficiency, you have getting greener, and also getting more flexible. In the past, you saw a lot of focusing on either chemical output or fuels kind of focus. What you see now is that refineries become more flexible in their output. So wherever they can make the most money, that's what they're going to produce in the future. So, and you see that flexibility more and more within the refining industry as well.
Isn't this where the molecule for the market comes in from?
Exactly.
That's a very common term.
Yes, that's where it comes from, definitely. You will also see that smaller, less efficient refineries are being closed down. They are reused, kind of, sort of, because especially with this whole energy transition going on, you see that a lot of waste oils are now being produced to produce biodiesel or biokerosene for planes to become more efficient, because otherwise it would be tossing away waste. But on the other hand, it's also neutral with regards to CO2 production and emissions during the processing of it as well.
Sure. Okay.
So you see that as well. But I know you are pretty much knowledgeable on power and energy. Also, the power plants are closing down a little bit as well, or changing over even. So what's happening there, Jenish?
So when we look at power itself, right now, the global capacity, 60% of that capacity comes from the coal-fired power plant. Even if we don't like it, that's the way it is. The rest of it comes from renewables, maybe even hydrogen, nuclear, etc. But then when you hear the word coal-fired power plant, this is the moment you burn coal, you are going to produce CO2. I have some statistics for you. For every ton of coal, you have an energy content of 29,000 gigajoules, which when you convert into power, it comes to around 2,500 kilowatt hour of electrical energy. But when you use coal to produce so much electricity, you also end up with 2.42 tons of CO2. Okay? So that's the situation. And if you want very simple numbers, simple KPIs, for 1 kilowatt hour of energy produced, at this moment, if you have a coal-fired power plant, then you have approximately 800 to 900 grams of CO2 emitted.
Yeah.
Okay? Now, when we talk of transition from coal-fired power plant to maybe in the future to hydrogen, that would be the ideal scenario, because then you are looking at a situation where there is just no grams of CO2 emitted. But that is still a work in progress. At this moment, they are looking at the transition fuel like natural gas. When you use natural gas, we are talking of combined cycle gas turbine. And that's where they reduce the emission to around 300 grams per kilowatt hour. But now they are also testing a blend of hydrogen with methane. Okay? And now they are also trying to optimize this blending process. And that's where, in fact, we are engaged with customers with our Raman spectroscopy to identify optimization opportunities over there. Okay? Now, in fact, if you look at existing coal-fired power plants, they are also not behind on this topic. They are also doing carbon capture. They are piloting with this thing. And eventually, they will be, matured and going from just being a piloted one to a matured stage. But now talking of natural gas being used for, this energy transition, we have Prashant with us. And Prashant, can you share what is the overall role of natural gas in the whole energy transition?
Yeah, the big topic in terms of the natural gas discussion is whether natural gas is a transition fuel or a destination fuel. Yeah. It's a bit of a tricky situation to give a clear response to that. There are different schools of thought here. In my point of view, natural gas is definitely a destination fuel compared to a transition fuel. The reason why I say that, burning natural gas has got lower emissions compared to burning traditional fossil fuels like oil and coal, and it is all about availability. Today, natural gas is available in different parts of the world as pipeline gas or in the form of LNG. There is a globally integrated network of LNG facilities, the liquefaction facilities, the regas facilities that is available. And the next 30 years, this number is going to go to double. That means there will be availability of natural gas in the form of LNG. Now, looking at the energy mix, we are starting to see large-scale development on the renewable space. My response is taking into consideration next 30, 40 years timeline. That is where natural gas is definitely a destination, because whether it is renewables or the new energy segment won't have the real scaling up of the volumes available to cater the market needs.
Exactly.
So in that respect, 30, 40 years, it is natural gas. And if I were to make a comment on next 60, 70, that will be too much of a speculation, which I will stay away.
Thank you, Prashant. And now, when we talk of energy transition, chemical industry cannot be forgotten in this context. So we have Phil with us. Phil, I have a question for you. In the context of chemical industry itself, how does circular economy help energy transition?
Well, let me explain first of all what is linear economy. What we take oil and gas as a feedstock, also to run our chemical processes, and for example produce plastic. This plastic is in use for packaging for half a year, textile 5 years, or construction parts for 35 years on average. And after that, we're gonna throw it away. It's waste or it's CO2 with a thermal oxidation. So these two options we're gonna have with today's cycle. And we think of it now, when we take we have the choice to either use the plastic or the materials will be put into the market for a longer period of time, reuse it in a different context, or we recycle the plastic, we recycle the waste, or we capture and use the CO2. So the first point is related to us as a user, how we're going to use it. The second point, the recycling of the waste and the reuse or capturing of the CO2 is affected the industry. When we talk about the recycling of the waste, we have several options where we can put the plastic into the olefin on the plastic polymerization chain. We can make a pyrolysis, for example, to really put it or gasify it and olefy it, and then the olefin chain begins from the beginning. We also can break it down into monomers and then repolymerize this. We can dilute it into chemicals, extract the plastic, or we take the plastic as it is, clean it, wash it, and pretty much put it into an extruder. So these 4 options we have. And this depends really on the quality of plastic, how we're going to use this in the end. And the last one called virgin-like plastic. This is one thing how we can use this one, but also here the feed streams and so on, they are not developed, and the cleanability, or let's say the purity of the feed stream, of how we get the plastic, this is from utmost relevance. When we maintain the processes as we have them today, so then also I agree with Rob, we see a lot of efficiency processes today because first of all, when we think of carbon capture, and then we have to think of storage or use it. So the infrastructure is not there yet. You can capture it, but we cannot use it today, or we cannot store it today. This is a big disadvantage what we have today. That's why the chemical, they're focusing really on the efficiency of the processes and also increase the space-time yield to reduce the energy. 75% of the carbon emissions in the chemical industries is coming from the energy production. And 25% is the release of the chemical processes itself along the value chain. So now when we think of that one, what we want to do with the CO2. And this is now also when it comes to hydrogen, it was a topic as well. We derive CO2, CO2 is an end product. It's on the lowest level, energy level, like water. And when we have compared CO2 with water together to use it, to make use of it, what we're doing today. Today we distinguish water. So CO2 and water, they're non-reactive materials and non-usable for the chemical industry, which means we have to put in both cases a lot of energy to lift them to the next energy level to make them reactive. And this is the key bottleneck what we have there. And that's why I don't want to be in a chemical decision of a chemical plant manager to decide whether I go for carbon capture and usage, because then you create permanent operating cost, which is very expensive, or you go for the renewable part. But on one hand, as Prashant said, the renewable part would be the best option, but is the technology available in the masses? No. Is the storage capacity available in the market? I think they're both technologies going hand in hand together, and it will be very difficult to make a proper investment decision because the cost, or the cost reduction on the renewable energy which is expected could outpace also the carbon capture investment decision, which then finally you run it with continuous operational cost. And this is where what we see in the chemical today, where the people of course struggle with, and I think this was mentioned before, I think this was from Prashant as well, this is a very tricky investment decision to be made on that topic.
Thank you, Phil. When we discuss of energy transition, new energy carriers come into spotlight. Mm-hmm. And this will also result in some minerals getting higher demand. And to discuss this, I have Vernon with me. So Vernon, hi Vernon, which minerals will see higher demand going forward with this energy transition topic?
Oh, that's a good question. I think it's clear the energy transition needs minerals. So therefore, the demand of minerals needed to produce clean energy will increase drastically. I know I read a recent article which states that the production of these types of minerals increased will increase by nearly 500% by the year 2050 in order to meet the growing demand for clean energy technologies. So what does this mean for the mining sector? Well, basically, it's created an opportunity for the mining sector to position itself as a trusted partner in fighting climate change.
Okay. When we talk of electrification of mobility, we quite often hear the word lithium. Is this the only mineral which is affected, or the demand for lithium grows, or is there any other mineral affected as well?
Well, lithium plays a big part for sure, but we also see a big drive in key energy transition minerals like copper, cobalt, nickel, zinc, to name a few, not just lithium. I know huge electric vehicle companies like Tesla signed supply agreements with huge mining houses like BHP and Glencore. I know that Glencore, for example, has struck a cobalt supply deal with Tesla. This supply is coming from countries that we deal with, like in the DRC, which holds around 70% of the world's reserves of cobalt. We are working with a project in the DRC called Kamoa-Kakula mine, and this mine is set to reach in the region of around 800,000 tons of copper per annum, making it the largest copper mine in Africa and the second largest in the entire world.
Thank you, Vernon. When we talk of hydrogen as an energy carrier, then we also talk about fuel cells. Which minerals are affected in terms of demand growth when it comes to fuel cell?
That's a good question. Of course, I mean, there's a really big demand in terms of fuel cell technology. And for sure, platinum is definitely a mineral of choice, as it's used as a catalyst for the conversion of hydrogen into electricity. So because fuel cells have no moving parts and do not involve combustion, they can achieve almost 100% reliability, and are therefore seen as the energy solution for the 21st century. For South Africa, it has opened up new opportunities for platinum group metals, specifically platinum. I know South Africa is the largest producer of platinum in the world. In 2021 alone, South Africa produced around 130,000 kgs of platinum. And because of fuel cell technology, there will definitely be a growing demand of platinum in the near future.
Thanks, Vernon.
No problem. Janish, maybe just from my end, just a quick question. I know you used to work in this industry. So in your experience, how do you see the energy transition affecting the metals and building sector, for example?
Let me just share my thoughts on the building sector. I used to work in the cement industry as well. So when we look at cement industry itself, it has always worked towards improvisation. You know, when you produce clinker, it's basically calcination of limestone with other ingredients, and that happens at around 1400 degrees Celsius. And you don't use up all the heat over there. So what happens is, you take the waste heat and you produce electricity out of it, which also meets the demand of the cement plant. But then at the same time, when we look at regulations, there have always been new regulations being slapped onto on the cement industry, like reducing the SOx gas or the NOx gas. They have met with these regulations. They have installed scrubbers, and it works perfectly fine. So now when we look at CO2 itself, I think at this moment they are at a prototyping stage, and eventually this will become a regulation, and I'm very sure of it that cement industry or the building material industry will comply with this, okay? And I have a very positive outlook about the cement industry coming from there. Rob, you have something to add over there?
Yes, I mean, let's face it. CO2 is being produced in large amounts in the cement industry, also in the metals industry as well.
Yeah.
Okay. It's not let's change it over time kind of deal anymore. The environmentalists, they all say, look, if we're gonna increase the planet's temperature by 2 degrees, we're gonna have a lot of flooding. And as a Dutch guy, you know, living close to the door, to the sea. We don't want wet feet either. So the pressure is on, the technology drive is on, and you need cooperation within the whole industry, not just the power plants or just the gas plants or the chemical plants or the cement plants in order to realize that. You need a whole supply chain in order to change that and achieve that goal. And we're all benefiting from that as well.
Thanks, Rob.
And face it, oil will not go away. Refineries will not be closed.
Yeah, for sure.
Yes, it will grow not as fast as gas or as electrification and stuff like that as well. So we have to make sure that also those processes become cleaner and less environmental, have less environmental impact in achieving the over the environmentalist defined temperature increase now.
There was one last question. We have time for only one question. I think Prashant would be very excited to answer this one. Hydrogen. What will be the role of hydrogen in this energy transition? You very quickly touched on natural gas and renewables, but we want to hear from you about hydrogen as well, but a very short one.
I'll try. Janish, interesting question. Before I get into that, there are different explanations for the energy transition. In my view, energy transition, it is a structural change in the energy ecosystem to move into less emission sort of fuel mix. Now, if we look at the global situation today, we are talking about 35 gigatons in terms of CO2 emission. That number needs to drop down to 18 gigatons in 2050, middle of the century. So it's basically need to cut down by half. How that is possible? We need to move away from the traditional fossil fuels.
Exactly.
One of the mediums which has been looked at is hydrogen as an energy carrier. Hydrogen is not a new topic. As Rob, Phil mentioned, this topic is there in the refining industry, in the chemical industry since last 30, 40 years. But hydrogen as an energy carrier is picking momentum. Now, there are a spectrum of different colors of hydrogen varying from gray to blue to green. Today, 95% of hydrogen produced is still gray and blue with carbon capture. We are also seeing some development on the green hydrogen side of things, electrolyzer. There is quite a lot of innovation, technology advancements, alkaline, PEM, new electrolyzer technologies on. So what we need is hydrogen will definitely play a key role in the energy transition, but we need to also find the right balance between the 2050 decarbonization goals and also ensures that we have energy stability, sustainability, and security.
Thanks. That is a nice closing statement from you, Prashant. Thank you, guys, for participating in the panel discussion for energy transition as a whole from hard to abate industries. Thank you very much.
Thank you, Janish.
Welcome.